Welcome back, mathematicians. In our last lesson, we worked on simplifying, multiplying, and dividing rational expressions. If you're not sure how to do those skills, I would definitely back up and go watch that video in the sequence, as it's very important to today's lesson. Today, we're adding a new layer, how to add and subtract rational expressions when the denominators don't match. And just like with regular fractions, the key is finding the least common denominator. But here, instead of plain numbers, we're dealing with polynomials and expressions. So factoring becomes really important. Once we factor the denominators, we can build that least common denominator, rewrite each fraction, and then combine them into a single simplified expression. In this lesson, we'll start with an easy problem, as you see here, where the denominators are already the same. And then we'll move on to examples where you have to do factoring and also where you have to find those least common denominators. In this example, and this is the easiest of the examples, so I'm just going to bring it down here. We're going to go straight across. You can see that the denominators are the same. This is exactly like what we would have if we had fractions with not expressions in it, just plain old fractions, such as 2/5 plus 1/5. Remember that the way that we add this, since it is already a common denominator, we keep it as fifths because we're adding and subtracting, and we just add the numerator. 2 plus 1 is 3. That's exactly what we're going to do here as well. Since the denominator is the same, we are going to keep that common denominator. And we're going to combine the numerator with addition. So we have x plus 2 plus 3. And since there's only one x, we will rewrite the x. 2 plus 3 is 5. And this is our final answer. Let's do one that's a little bit more challenging because now, as you see, we do not have a common denominator. What we do have, though, on this side is a difference of 2 squares. Remember that in order to handle a difference of 2 squares, we can factor this into a and 2 and 2. 1 is positive and 1 is negative. So if I rewrite this with this denominator factored, I'm going to get this problem. I'm going to go ahead and put it in the middle. We have 5a plus 6 all over a plus 2 and a minus 2 minus 1 over a plus 2. Now you might be recognizing already that this one only has an a plus 2, like this one. It does not have the a minus 2, so we need to give it the a minus 2. The part that's different is what we need to give it. We can do that by multiplying the other fraction by a minus 2. And so that we are not changing the value of this expression, it has to be a minus 2 over a minus 2. Remember that anything over itself is equal to 1, even if it's a variable and even if it's an expression. So whenever you multiply by 1, you're not changing anything. Now you can see we have a single common denominator. So we're going to write that final common denominator down here. This is going to be 5a plus 6 in the numerator minus 1 times a minus 2. Now this is kind of important that we're putting everything that we're multiplying by into a parentheses. Let me move this over just so I have a little bit more room this way. That's because we want to make sure that this subtraction sign is multiplying with everything that's in this numerator. So in the end, we need to show that we're distributing this -1 to both the a and the -2. That changes our numerator to 5a plus 6 minus a plus 2. Again, still over a plus 2, a minus 2. 5a minus a leaves 4a. 6 plus 2 is 8. And now we have that over a plus 2, a minus 2. Now technically we're done adding and subtracting, but what we are not done with is simplifying. Remember, with fractions we always have to check and see if they need to be simplified. And in this case, we can actually factor that numerator. We can divide both the first leading coefficient and the constant by 4, and we're going to get a different numerator. We have 4 parentheses a plus 2. And that's really important because our denominator also has an a plus 2. And if you remember right, with simplifying, that's what we're going to do. We're going to cancel the a plus 2's because anything over itself is 1. And now I have my actual final answer of 4 over a minus 2. And that was a lot of work and a lot of refreshers on how to find common denominators. For our next problem, let's bump up the challenge level a little bit so that you can see what happens if neither of the denominators shares anything. When I first look at this, just like usual, I am going to notice that this is a quadratic with a leading coefficient of 1. So in my mind, one of the easier ways to factor. And then this is a difference of 2 squares. And as long as you recognize that it's a difference of 2 squares, which can sometimes be hard to do, I think that's probably the easiest way to factor because it's like a template. So we're going to put z as the beginning for both of these. 6 has factors of plus 2 and plus 3 that add to 5, and everything's positive, so that is now factored. Z squared minus 1, the z is going to be split into 2. The 1 is going to be split into 1 and 1, and we have a positive 1 and a minus 1. Now, the kind of cool thing that you might have recognized here is that in each case, the numerator shares something with the denominator. And you might be thinking to yourself, can't I simplify that to get rid of it? And the answer is yes. Because this is separated by subtraction, this side can simplify with each other, and this side can simplify with each other. But be very careful. If there was a z minus 1 over here, we would not be able to cross simplify because of that subtraction. But in this case, we can take z minus 1 and z minus 1 and get rid of it. And here we can take z plus 2 and z plus 2 and get rid of that. So now when we're rewriting this, it's a lot easier. On this side, I have a 1 in the numerator, and I have z plus 3 in the denominator. And I just realized I'm going to need a little bit more room than that in order to find common denominators. Remember that we are subtracting, and over here we have a 1 in the numerator and a z plus 1 in the denominator. Now, just like the last example, these do not share a z plus 1, and they don't share a z plus 3. So you have to give them whatever they are missing. So on this side, it needs a z plus 1, and this side needs a z plus 3. But I can only do that if I'm multiplying times 1. So I have to put these in the numerator as well. Now we're going to do all of this multiplication and come up with a single denominator. The single common denominator is z plus 1, z plus 3. Just like that. 1 times z plus 1 is z plus 1 minus, be very careful, z plus 3. Now, a common mistake that students make at this point is you think that you can cancel these because it's up and down. If this was multiplication, that would be true. Since it is subtraction, you cannot. Instead, we need to distribute this negative to each side in the parentheses and rewrite this. So we have z plus 1 on top minus z minus 3, and our common denominator of z plus 1, z plus 3. Z minus z is 0. So now we have no z's in the numerator. 1 minus 3 is negative 2, and our common denominator is z plus 1 and z plus 3. This is my final answer in factored form. Another way that your teacher might ask you to do it, although it's not as common, is to put it back into its polynomial form. It is important to be able to do both of those things. Now, don't forget that down below is a link to a free worksheet resource practicing these in exactly the same way that I've just taught it, and you're welcome to back up in the sequence to learn anything that might have been rusty for you as well. Good luck, mathematicians!